Stoichiometry calculations. Let's start off with a simple reaction. Let's do the reaction between hydrogen and oxygen to produce water. So the first thing we need to do is always balance those reactions. And then the second thing we do is we make our BCA table. So I'm going to do 3 sample BCA calculation problems. In this first one, there is 2 grams of H2 reacts with 2 grams of O2 to produce water. What mass of water and excess reactant exists when the reaction is complete? So I'm going to go ahead and do that. Step 1, we always want to balance the reaction. So H2 plus O2 goes to H2O. I'm going to go ahead and use a different color here. So 2, 1, and 2. And we're then going to make our BCA table. So solid line through the reaction, dotted line here, B, C, A. Okay. And I need to take these 2 grams and I need to convert those over to moles. So the first thing I'm going to do when I do that is I'm going to do it with H2, and I can use the periodic table here because it's not in liters. So I know that you have 2 grams of H2 per every 1 mole, and 2 grams would be X moles. So we have exactly 1 mole here, which is really convenient. So I have 1 mole of hydrogen here. And now I have my oxygen here. So I know that O is 16. 16 times 2 is 32. 32 grams per 1 mole. When you're doing mole conversions, the left side always has the molar mass, and the right side always has that X. Okay. So now I have 2 grams is equal to X moles. And when I solve for that, I'm going to get 2 divided by 32, which is going to be 1/16. So 2 divided by 32 is 0.06. So this is going to be 0.06 moles, and this is 0 moles. So I'm going to carry out the BCA table by first deciding which one am I going to run out of first. We call that our limiting reactant. Well, in my recipe, it calls for double the amount of hydrogen as compared to oxygen. And here I have way more than double. If this was correct, this should be 1 and this should be 0.05 or 0.5. This must have to go way up to get to 0.5. So oxygen is going to be the limiting reactant here. Doesn't make sense conceptually, but that's who it is. So this is my reference. So everything is going to be referencing this 0.06. So that's going to be 0 moles. Okay? And this is going to be 1 minus 0.06 multiplied by these coefficients here, because for every 2 H's, there's 1. So this is 0.06, but this is not 0.06. This is 0.06 multiplied by 2, because there's a 2-to-1 relationship between H2 and that. So here now, I'm going to find out what that is. So 0.06 times 2 equals that, minus 1. That's 0.88. So this is going to be 0.88 moles. And here now, I'm adding on this side. Anything below the 0 is always a plus, because I'm gaining water in this reaction, multiplied by the reference, so 0.06, multiplied by 2 over 1 again. So that's going to be 2 over 1 here. So 0.06 multiplied by 2, that should be 0.12. And I get 0.12 moles. So when this reaction occurs, if 2 grams of hydrogen reacts with 2 grams of oxygen, I'm left with 0.88 moles of H2 left over, and I produce 0.12 moles. But it's asking for a mass of water. So I need to take this answer and I need to convert it to grams. So let's go ahead and do that over here again. So I know that water is 2 hydrogens and 1 oxygen. That's 18 grams per mole. So here I have 18 grams per every 1 mole is equal to x grams over 0.12 moles. So now I'm going to take 0.12 and I'm going to multiply that by 18, and I'm left with 2.16 grams of water. Okay, let's try another problem. Let's do one where we have PV equals nRT involved. So let's say if 0.5 liters of C3H8 butane gas burns in 0.5 liters of O2, what mass of H2O and CO2 are produced? Okay, so the first thing we're going to do here again is we're going to balance the reaction. So C3H8 plus O2 goes to CO2 plus H2O. So this is 3, this is 4, and this is going to be 5 to balance it out perfectly. BCA, boom, 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 dot, 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 dot. Okay, and we're gonna just divide this up. Here's my cooking side. So I have 0.5 liters. Now, if that was grams, I could use the periodic table, but I'm not. I'm gonna use PV equals nRT, and I have 0.5 liters of O2. So if PV equals nRT, I always want to be solving for n. Remember, in a BCA table, we always put things in terms of n. So n equals PV over RT. Okay? And in this problem, in order to do it, I would have had to tell you what the pressure is. So let's say this reaction occurs at 25 degrees Celsius and 1 atm. Okay, so room temperature, atmospheric pressure. So 1.5 over R, 0.0821 multiplied by 298. Okay. So when I go through and I do that, I'm going to take 1 times 0.5. I'm going to press equals, divide that by 0.0821, press equals, 1 times 0.02. And because I'm using PV equals nRT and it's based on moles, not grams, I have the same number of moles of each of these, 0, 0. So according to the balanced reaction, I need 5 times as much O2 as I have propane. I don't have anywhere near that. Okay, if I had 5 times that, that would be 0.1. So I know that this is the one I'm going to run out of. So I have 0.02 minus 0.02. That's 0 moles. And this is going to be 0.02 minus 0.02, and it's this 0.02 multiplied by this relationship here, which is 1 over 5. Notice that the reference is always on the bottom. So let's get what that is. So that's going to be 0.016 moles. Okay. This is going to be 0 plus 0.02. Now it's this 0.02 multiplied by 3 over 5. So 0.012. And this is going to be 0 plus 0.02 multiplied by 4 over 5. Notice that the 5 is always on the bottom. That's 0.016. And it asks for grams of each. So now we have when 0.5 liters of both propane and oxygen burn, you're left with 0.06 moles of propane in excess, no excess O2, okay, that'd be a really slow burn, and you're left with 0.012 moles of CO2 and 0.01 moles of H2O, and let's go ahead and do that. So the molar mass of CO2 is 44 grams per every 1 mole. So how many grams would be 0.012 moles? So 0.012 times 44. So that gives me 0.53 grams of this right here. If I did the same calculation for water, but I replaced it with it, so let's do it down here. 18 grams per every 1 mole water, x grams, 0.016, cross multiply, 0.016 times 18 equals 0.28 grams. Okay. So I encourage you guys to write this down and pause the video, do it, and see if you get the same answer.